Hello everyone, welcome to my channel Ultimate Physics. So today we are going to start our lecture 4. So let's start. Today we are going to discuss acceleration. It is called rate of change of velocity. This can be betterly understood by this formula. So change of velocity is v minus u. So acceleration will become rate of change of velocity as we have divided it by t, and we will get acceleration. So let's move further. It is a vector quantity. This means that it is the same vector. It also has direction, and it can be positive and negative. Also, it is same to the velocity and average velocity which we have covered earlier, because those are also vector. This is also vector. This is the similarity between velocity and acceleration, but this is only similarity between them, that they both are vector. So it is represented by a, the first letter of acceleration, a. Its formula is v minus u by t, which you can see here. V minus u by t, i.e. rate of change. It is rate of change of velocity, so change of velocity by time. Its SI unit is meter per second square, not meter per second. It is here by mistake. Sorry for this. Meter per second square. It can also be negative. It is a vector quantity, so it will be a negative. It can be a negative quantity also and positive also. This can be understood better by this example. Suppose there are two accelerations on this object. One is on right side, one is on left side. So this will mostly we take right side as positive and left side as negative. So this will be positive acceleration, and this will be negative acceleration, which is called retardation also. It can be uniform or non-uniform. This is a very important topic. Uniform means that when the acceleration is same throughout the journey. We can understand this by this example. So suppose there's an object which is falling from a particular height, so it will be in under acceleration due to gravity, which we call g. Its value is generally taken as 10 meter per second square. Okay, so it will be continuously under acceleration while he comes here and here, and till reaching the ground. It will be with same acceleration 10 meter per second square. Now take an example of non-uniform acceleration. This can be understood by an example of a car moving on a crowded road. So some people may be standing here, and another cars will also be there. So this will make its acceleration non-uniform, as the car has to apply brakes and then accelerator again and again. So now we are going to discuss some numericals on acceleration to make the concept more clear. A car accelerates from 36 km per hour to 72 km per hour in 10 seconds. Okay, so now we are going to find the acceleration of this. So let's move to the whiteboard. Here comes our whiteboard. So first we can write initial velocity. Initial velocity is 36 kilometer per hour, which is equal to 36 into 5 by 18 meter per second. We have to convert it to the SI unit of velocity, which is meter per second. You will be thinking that why I had taken this as 1 5 by 18. This is because if this is a shortcut method for converting to meter per second. If this otherwise it would be a longer method. If you make this 36 kilometer to meters and then this r to 60, uh, i.e. 60 into 60 seconds, which is equal to 3600 seconds. So when we will cut it, this kilometer per hour, 1 kilometer per hour, when we will cut it, it will become 5 by 18. So this will become a shortcut method for us for solving questions. So we will just cut this will become 1, this will become 2, and our initial velocity will become 10 meter per second. So we will note it down here, u equal to 10 meter per second, and we will erase the rest. It's a little bit time consuming, but no problem. So let's see the question again. So it accelerates from 36 kilometer per hour to 72 kilometer per hour. So our final velocity is 72 kilometer per hour. So let's write it 70. Sorry for this. Forget about it. 72 kilometer per hour, which will become 72 into 5 by 18. So this will become 1, and this is 4. So our final velocity will become 20 meter per second. Okay, so let's note it down here. 20 meter per second. Also, our time taken is 10 seconds. So let's calculate our acceleration. Everybody knows acceleration equals to v minus u by t. So here v is equal to 20, u is equal to 10, and time taken is also 10. So it will become 10 by 10 equal to 1 meter per second square. Okay, I think it is clear. I think it will be clear to all. So let's move to our questions again. So let's now do second question. What is acceleration if speed is constant of a body? So if speed is constant, this is a very important point. If speed if speed is constant, then acceleration equals to 0 meter per second square. This is very important point. You can understand it by this. If there is no increase in speed, then acceleration will be 0, as acceleration causes an increase in speed or velocity. So if there is a constant speed going on, then acceleration will be 0. Okay, I think it will be easy to understand. So let's now move on to the third numerical. A truck is traveling at 90 meter per second, and then it is slowed down to 30 meter per second in 10 seconds. Then find the acceleration. Then find acceleration. Okay, So we can do it on the whiteboard. Here we are also given with the SI unit, so we need not to convert it. Simply here we will solve it. So initial velocity equal to 90 meter per second, final velocity equal to 30 meter per second, time taken equal to 10 seconds. So acceleration will be 90 minus 30 by time taken, which is 10 seconds. So it will become 60 by 10. We'll cut the 0 and our answer will become 6 meter per second square. This is your answer of the third numerical. So let's now go to our next slide as our all numericals are over. This is today's last topic, equations of motion. This is very and very important topic. Very, very important. It is important as it will not only come in ninth standard, but it will be helpful till every class. Till then you study physics. It will be very helpful for you. So there are three equations in ninth standard. There are three equations of motion. All should be learned at fingertips. These are very important. If the or most of the questions will be from these in your exam, so these are very important to be learned. So these are v equal to u plus at, then s equal to ut plus half at square, and then 2as equal to v square minus u square. So here initial velocity is u equal to initial velocity, then v equals to final velocity, here s equal to displacement or distance, then here acceleration is a and time is t. So today we are going to derive the first equation. So everybody will be remembering the formula of acceleration, which is v minus u by t. Okay. So and then we will take this t there, so it will become at equal to v minus u, change in velocity equal to acceleration into time. So here v will become u plus at, and this is your first equation of motion. This is very important. So in our next lecture we are going to discuss some numericals on our first equation of motion, and also going to derive the other two equations of motion. These are very important. You may take the screenshot of these to learn them, otherwise they are also there in NCERT books. Also, if you don't have a NCERT book, you can download its PDF. In this video I will in the description of this video there will be a link, you can download it from there. Okay, bye bye, hope you enjoyed. We will meet in our next lecture.